Continuing on in our discussion of U substitution, we have done U substitution with some algebra problems with indefinite integrals. We have done definite integrals, and in your packet you will find the document that you see on the screen. It is a review of evaluating definite integrals using U substitution. It's the same thing that we saw in the prior video on that, but it is in your packet and it shows you the step-by-step with annotations. If you want to review that again, take advantage of that. If you're in my class, we're going to start with the warm-up. If you're not in my class, you might want to move on to the actual lesson. But if you're in my class, stop the video or turn to this page, do the warm-up, stop the video, and then check your work to see if you did the problem correctly. All right, here we go. In this warm-up, we've been given a function, and we're to find the average value of this function from 0 to 2. We know that to find average value, we're going to evaluate 1 over b minus a. Because when we find an average, we divide by the amount of, quote, stuff that we have. So this is going to be the division. We're going to accumulate the area from a to b of f of x dx, which is the same thing. Some books will write it this way. The accumulation a to b of f of x dx, and you can actually see the division, which when we evaluate it is going to give us the original function big F of b minus big F of a. There's the fundamental theorem of calculus, divided by b minus a, and that's going to give me an average. All right, so in this problem we're going to have 1 over b minus a, so that'll be 1 over 2 from 0 to 2 of x e to the negative 3x squared dx. All right, I'm going to do this problem with U substitution because I have an inside and an outside function, so I'm going to let u equal to negative 3x squared, and du is equal to negative 6x dx. I will not need that negative 6, so that's going to give me du over negative 6 is equal to x dx. I'm going to make my substitutions, and that'll give me a 1/2 out front. I'm going to take the negative 1/6 out front and get it out of my way. In place of x dx, I substitute the negative 1/6 du, so there's my du in the back. And I'm going to substitute u in place of negative 3x squared, so I get e to the u. And I'm going to change these x bounds into u bounds, so I'm going to substitute 2 in place of x. 2 squared is 4. 4 times negative 3 is negative 12. Substitute 0, and that gives me 0. Notice that my bounds are out of order. So let me clean this up a little bit. This is negative 1/12 from 0 to negative 12 e to the u du. Since my bounds are out of order, I'm going to use properties of integrals, and remember, when you change direction, you change the sign. So this negative 1/12 becomes positive 1/12 e to the u du. Okay, again, changing the order of the bounds. So when I find the antiderivative of e to the u, I get e to the u evaluated from negative 12 to 0, which is 1/12 of e to the 0 upper bound minus e to the negative 12 lower bound. E to the 0, oops, see, I already dropped a 1. E to the 0 is 1 minus 1 over e to the 12th. And I can get a common denominator and make that 1/12 of e to the 12th over e to the 12th minus 1 over e to the 12th. So that would give me e to the 12th minus 1 over 12e to the 12th. And that is the average value of the function. So let's go on to the lesson, or this is actually part of the warm-up. The second item in the warm-up, we're going to find the antiderivative of 2 over x. Remember, from the properties of integrals, we can pull that 2 out front and make this the antiderivative of 2 times the antiderivative of 1 over x, and we know that the antiderivative of 1 over x is ln of the absolute value of x plus c. It's an indefinite integral. In general, the antiderivative of 1 over x is ln absolute value of x plus c. Now we're going to reverse the chain rule with ln's. So the antiderivative of u prime over u is ln of the absolute value of u plus c. So we're reversing what we already know. Bear in mind, the derivative of ln of u is u prime over u. Therefore, the antiderivative of u prime over u is ln of the absolute value of u. All right, let's use that to deal with these fractions that we're dealing with now. So we're going to use u substitution because there's an inside function. We're continuing on with the whole idea of u substitution. U is equal to 2x minus 1. Du is equal to 2 dx, and we don't need that 2, so take it to the other side. When we do the substitution, we have 1/2 of the integral of 1 over u du. Now notice we can't use the power rule or reverse the power rule here. If you try to do u to the negative 1, if you increase negative 1, you get 0, and you can't divide by 0. So we know that the antiderivative of 1 over u is ln of the absolute value of u. And there's my plus c, and then I'm going to make my substitution. 1/2 ln absolute value of 2x minus 1 plus c, reversing u prime over u. Easy stuff. All right, number 2 says find the area of the region bound by this curve from 0 to 3 and the x-axis. So we're going to accumulate the area starting at 0, stopping at 3 of x over x squared plus 1 dx. There's an inside and an outside function, so I'm going to let u equal to x squared plus 1. Du is equal to 2x dx. Get rid of the 2, and we get x dx. I'm going to put my 1/2 out front. I'm going to substitute in place of x dx. I've already put that in, so I have the du, and I have 1 over u, because x squared plus 1 is equal to u. Find the, and let's change my bounds. So my upper bound of 3 becomes 3 squared plus 1 is 10. My lower bound of 0 becomes 1. So I have 1/2 of ln of the absolute value of u, evaluated from 1 to 10. So that's 1/2 of the ln of 10 minus the ln of 1. The ln of 1 is 0, so we have 1/2 ln of 10, which is the same thing as ln of the square root of 10. Now, how did I do that? I used a log property to put the exponent back on. So just be aware that although you may not have to write your answer with the log properties, you may encounter a multiple choice scenario where you have to recognize that 1/2 ln of 10 is ln of the square root of 10. Let's do number 3. Inside-outside function, let u equal to the denominator, x cubed plus x. Du is equal to 3x squared plus 1. How convenient. So when we find the antiderivative, we get 1, dx. We get 1 over u, du, which is ln absolute value of u plus c when you find the antiderivative. So resubstitute ln of the absolute value of x cubed plus x plus c. And number 4, u equal to tangent theta. Du, the derivative of tangent theta is secant squared theta. These all come out so nicely, don't they? And then you substitute, and you get 1 over u du, ln absolute value of u plus c. Resubstitute ln absolute value of tangent theta plus c. All right. Tangent theta, we do not know the antidifferentiation of tangent theta. So what are we going to do? Well, change it into a quotient. Sine theta over cosine theta, d theta from 0 to pi pi over 4. I'm going to let u equal to the denominator of cosine theta. The derivative of cosine theta is negative sine theta d theta. So that's going to give me a negative out front, and 1 over u du. I'm going to change my bounds. I'm going to put the cosine of pi over 4 is root 2 over 2. The cosine of 0 is 1. So that gives me negative ln absolute value of u evaluated from 1 to root 2 over 2. Give myself more space here. So that'll give me negative ln of root 2 over 2 minus negative ln of 1. The ln of 1 is 0, so I get negative ln of root 2 over 2, which is the same thing as ln of 2 over root 2, because I can take the negative power back on here. Okay, that's all. So your homework is on Edline, and it should be pretty straightforward.